Hello and welcome to video number 9, Administering Linux Part 3. This is part of Fast Track CBT Video, Linux Networking and Administration. Let's take a look at our table of contents. So in this video we're going to talk about manage and access mail queues. So we'll learn about the send mail program and how to read your mail. We'll learn about scheduling jobs with cron and at. Talk about managing run levels and system initialization. And finally, tuning kernel runtime parameters. So first off, we'll talk about manage and access mail queues. Now, this is an important topic, but one of the reasons we're talking about it is because it's based on Linux Plus Objective 2.21. And that says manage and access mail queues, for example, SendMail, Postfix, Mail, and MUT CLI utilities. Now, a Linux server can function as a mail server. This software is included for free on the Fedora Linux installation media. So, your Linux server can be an email server. There's no additional email server license or anything like that you have to buy. Even if you aren't using your Linux server as a mail server for a company, you may still run mail server software for administrative email updates. For example, cron email updates about batch processing jobs are sent to the root email account whenever there's a success or a failure. And we're going to talk about scheduling jobs with cron in just a second, but a lot of administrative emails are automatically generated by a Linux server and they go to the default local mail server. And then the local root user is expected to check their email account to see what administrative messages they received. So SMTP is Simple Mail Transfer Protocol. It's used to send mail either from a PC to a mail server or from a mail server to a mail server. So if you have a PC running, say, Outlook Express on a Windows XP system, you use SMTP typically to talk to your email server to send that mail. That mail server sends it to another mail server with SMTP. Now, when you receive mail, you don't use SMTP. You use either POP3, IMAP, or RPC if you're using Microsoft Outlook. Properly configuring an email server is far beyond the scope of this Linux training, so we're only scratching the surface about email server configuration. Now, SendMail is the original Linux and Unix mail server. Information on SendMail can be found at sendmail.org. Just because you have a program called SendMail doesn't mean that SendMail is your mail server. Some vendors will create a link to their binary or a copy of their binary because so many programs are looking for the SendMail file. Now, the SendMail configuration file is located at sendmail.cf in the etc directory. This is a very complex file. Most administrators use the M4 utility to create their configuration and then convert it to the SendMail file. In fact, there's a whole O'Reilly book just on how to edit the SendMail file. That's how scary it really is. So you'll find that SendMail comes installed with Fedora Linux by default, so even without having to do a thing, Fedora installs and starts SendMail. Now, Postfix is another mail server. It isn't as popular as SendMail, but it's the default mail server for Mandrake and SUSE Linux. Postfix is simpler to use than SendMail, and it has less features too. But it's a good mail server. The Postfix configuration file is located at etc postfix/main.cf. You'll find it has a lot of comments, and it's very easy to edit. So now let's talk about mail queues. Mail queues are where the mail lines up on the Linux server. So we talked about print queues. That's where the print jobs line up. Mail queues are the same concept. This is where the mail lines up, or the email lines up. So if you're using SendMail, you can use the SendMail-BP or the mail queue program to view what mail is in the mail queue. Say that you've had a networking problem or other problem that's caused your mail server to have mail queued. You correct the problem and want the mail server to retry sending the mail in the queue. To do this, you can use sendMail -Q to try to resend all mail in the queues. Now to check your local email on your Linux server, you can use the mail command. Mail is just a tiny little simple program. It tells you what mail's in the queue. You can delete it, you can reply to it, just the bare minimum. Now the mail command also works to send mail on a Linux server. So I can send an email using the mail command, either from the command line or by going into the program. Now root's mail is stored at var spool mail/root, and so are the other users' mail files stored at var spool mail and then whatever the user is. If you read a message but you don't delete it with the mail program, that undeleted message, but the read message, will be stored in a file called mbox in your home directory. So it'll leave the mail that was unread in this folder up here, but it'll leave the mail that was read but not deleted in a folder called mbox. Now another program to read mail is Mutt. Mutt is a text-based program to read mail, but it has more functionality than the mail program over here. Mutt is a more like a menu-driven program. It has a little command line toolbar thing at the top. Other well-known programs to read mail on Linux and Unix systems are Pine and Elm. Mutt is installed by default on Fedora Linux, so I'll go in and we'll show you Mutt here in just a second. Of course, you can use the OpenOffice.org graphical mail client called Evolution. That's installed whenever you install OpenOffice on Linux as well. So it's more like Microsoft Outlook Express when it comes to sending and receiving mail. Full functionality. It supports the local mail files here as well as POP and SMTP and even a variety of other protocols. So it's a very nice email client for the graphical interface. So with that, let's check out how mail works on the Linux server. So if we go over here to our mail server, I'm going to open up the terminal window and maximize that. And first let's check to see that this sendmail program is running. And sure enough, we've got a sendmail daemon, actually a couple different programs that make sendmail work. Both of them running, accepting connections it says up here. So let's type mail. And you can see here I have 2 email messages. It says it found them in var spool mail root. 2 messages, 2 unread. So this is the mail program. This is the most basic way to read your mail. If I press 1, it'll show me the message. And like I said, this is an automatically generated log file that you just have to have mail to receive these types of messages. So if I scroll through here, you can see these system messages that came up. When I'm done, I can hit D to delete this message. I can press H for headers, and it shows me there's 1 message left, and it has a U next to it and it's unread. So if I type question mark, you can see here I can go to the next message with an N, I can delete messages with a D, undelete with a U, reply with a capital R or little r, mail to specific users. I can send an email from here, Q to quit, and H to print out the headers. So if I want to send myself a message, I could do M space root, and we'll call this test. I'll type in test here, and then Control D to terminate that. It says, do you want to carbon copy anyone? I'm just going to hit enter. And it should have sent me an email. Let's check. Let's type H for headers. No message yet. Let's get out. Let's go back in. There we go. There's our test message. So I had to exit out and go back in. And we have a test message, message number 2 here. It says it's new or in. I'm going to go into that message. And you can see there's the message right there. I'm going to delete that message. H for headers. I'm going to delete 1. H for headers. No mail. I'm going to quit. So we cleaned out all our mail. We used the mail program. You can also use mail from the command line like this. I can do mail, root, press enter, and it's the same thing, just like I was sending it inside the program there. So I'll call this test 2, put test 2 in as the subject, or as the body, Control D to terminate. And I didn't carbon copy anyone, and I sent myself a message. So that's the mail program. Let's type in mail queue, and it says that var spool mq is empty. That's the send mail queue to send out messages out from the server. So right now this server doesn't have any mail to send out. Let's try out the MUT program. If I type mutt, so here we are inside the MUT program. You can see across the top there's a menu bar that says Q to quit, D to delete, U to undelete, S to save, M to mail, R to reply, G to group. So here we are at this message, and this is like a scroll bar here that goes up and down. So if I hit up arrow and down arrow, I can scroll through the messages. Right now I only have one message, so it tells me I'm already at the first message. So if I press enter, it shows me that message. And you can see on the top it says I to exit. Space, next page, V, view attachment, D to delete. So if I type I and I exit, it brings me back. So we're not going to do a lot with MUT. I just want you to see how it works. This is MUT. It's basically the same as the mail program, but a few more features. So I'm going to press Q to quit, and it says move read messages to inbox. I'm going to say no. So it kept one message. So now let me close out of this, and let's go look at evolution. So across here on the menu bar on the top, the second little icon here says email, send and manage your schedule. So if I click on that, this is going to start up the evolution program, similar to an Outlook Express type program. So it has a little initial configuration here. So it asks for my name. I'm root. My email address is root@localhost. I'm not going to fill out any of that. Server type. Here's all the different types of servers it supports. Lots of different options. We're just going to use the standard Unix mbox, spool, or directory. So now it asks for the path. So it's important to know that path. var is right here. Spool, mail, root. So there's the path to our mail. I'm going to say forward. Automatically check for mail every so many minutes. Okay, that's fine. Server type. We don't really have an SMT. Well, we have our SendMail server. We can just use that. Obviously, it's not configured to send mail at this point out on the internet or anything like that. But I'm just going to put localhost as the server. Doesn't require authentication, and we'll say forward. So account name is root@localhost. That's fine. Time zone. Well, in Bozeman, Montana, at the Big Sky Fishing Company, it's mountain time. So let's find mountain time. Denver is mountain time. America/Denver. So I'll say forward. Congratulations, your mail configuration is complete. And here's the Evolution Mail client. So right here, there's inbox, drafts, things like that. But if I click on this root@localhost, click on my inbox, hey, there's that same email message right there. There's the test 2 that we sent ourselves. So I can click send and receive. It checks the file. I can click reply. And I'll say, this is test 3. Notice because this isn't a special mail format, this is just plain text, there's no bold and everything like that. Now if you use another mail format, it can do like HTML, just like Outlook Express, you can have all those different text editing features. So I'm going to say send, and send and receive again, and here's the reply. This is test 3. So you can see how that works. You could use this to check the administrative email on the mail server every day. And if you configured it properly, of course, you could send and receive mail on the internet with this every day. So that's evolution. So let's close this out. Alright, so we learned about mail queues, the SendMail mail server, Postfix mail server, the mail program, MUT, the text-based mail program, and of course evolution. So with that, we can move on to our next section. So now we're going to talk about scheduling jobs. Now Linux Plus Objective 2.22 says you should be able to schedule jobs to execute in the future using the @ and cron daemons. Now the @ program is used to schedule one-time jobs. So if I want something to run at 6 o'clock tonight, I use @ and I schedule it to run at 6 o'clock. It runs and that's it. It was a one-time job. The cron program is used to schedule reoccurring jobs. So the term cron comes from chronological, having to do with time. Things that are periodically done is what cron will do for you. So cron is where you would schedule a job to run, say, every Monday at 6 o'clock, or once a month, or every hour, or every minute, whatever it is you want to run. It's a periodic, reoccurring job. Both @ and cron support regular users and the root user. So root can do this, and so can regular users. Cron awakens once per minute and checks the following locations for jobs to process. These locations right here: var, spool cron, etccron.d, and etccron tab. There are some cron jobs by default, so Linux uses cron to periodically do things like clean up the temp folder. So there's some default cron jobs. These jobs are completely unsupervised. They should require or request no user input. That goes for @ jobs and cron jobs. They're batch processing jobs. You submit them, they run at some time without you, no one around, and they shouldn't be, asking any questions, and they shouldn't have any errors. That's for sure, because there's going to be no one there to try to fix them, right? So the etccron tab file is for the root/system cron jobs. So this etccron tab, this is for root or other administrative jobs. Now in the cron tab file, there are these fields. So the first field is what minute you want this job to run, and it's 0 through 59. The next field is what hour, and it's 0 through 23, so it's military time. The next field is the day of the month, so 1 through 31, what day of the month. The next field is the month, 1 through 12. The next field is the day of the week, so if you want this job to run every Monday. And the days are numbered 0 through 7, and 0 and 7 are both Sunday. So Monday would be 1, Tuesday would be 2, Wednesday's 3, and so on. An asterisk represents all possible values. So if you want this job to run every minute, every hour, every day, every month on a Sunday, you could put asterisk, 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 0 for the day of the week. So every Sunday it would run every minute, every hour on the Sunday. Or if you wanted it to run every Sunday at 6 a.m., you could put 6 for the hour and then 0 for Sunday and then asterisk for everything else. Now usually there are /etc/cron.interval files. So the interval would be cron.daily, cron.weekly, cron.monthly files. Make sure you test cron jobs thoroughly before running them. If they have an error and they don't finish, then the job didn't run at all most likely, or it ran partially. So they need to be fully tested to make sure they're going to work. Now as a user, you create your own cron jobs using the cron tab program. If you just want to run a program or a script one time in the future, @ is the program for you. To use @ you just tell it the time, or you can use -f and give it a script. So to add a job, you say @ space and then the time and press enter. And then it prompts you for what what programs to run. So you could type in a script name, or you could type in your own little ad hoc script. Now for the time, you can put it in hour, minute format. It'll also accept noon, midnight, or tea time. And I thought that was pretty funny. Tea time is 4 p.m. Us Americans don't know that tea time is 4 p.m. But it is. I guess I'll have to start having tea then. So if you use 12-hour format, you can specify either AM or PM. Optionally, you can specify a date if the time is more than 24 hours in advance. So with that, let's set up a cron tab. We're over here on our Linux server. I'm going to open a terminal window. And let's just look around a little bit first. So if we cd to Etsy, and I say cat cron tab, you can see here's the default cron tab file. I haven't edited this at all. So it says to run these in the bash shell, send mail to root upon successful completion or failure. And then it's using those interval files. So there's cron hourly, daily, weekly, and monthly. And you can see here, this is the minute. So every minute it's going to check the hourly file. There's asterisk for all the other fields. And then daily, it's going to check the daily file at 4 o'clock a.m. and 2 minutes. Weekly, it's going to check the weekly file on Sunday at 4 o'clock a.m. and 22 minutes. And then monthly, it's going to check, let's see, what is this? The first day of the month. The first day of every month at 4 o'clock a.m. and 42 minutes. So those are the defaults. So if we cat cron.hourly, oh, it's a directory, okay? Excuse me. We have to cd into cron.hourly and do an ls-l, and there's nothing in there right now. So if we put in a file in there, it's going to run it every hour. If we cd into cron.daily, do an ls-l, here's all the things that it runs daily. So these are scripts that are in there by default that happen every day. If we go back and we do cron.weekly, ls-l, these are the scripts it does every week. And if we go back and check out cron.monthly, every month it runs this. So what are these things? Let's check this one out. Anacron. Pipe that to more. So it says Anacron's cron script. This script updates Anacron timestamps. It's called through run parts either by Anacron or itself. This script is called to ensure that we executed before all other scripts. Anacron-u cron.monthly. Amazing. It's amazing all these different scripts that just run periodically on their own. They're in there by default. Linux just does this just when it's installed. And if you compare that to, say, a Windows server or a Windows XP machine, there's nothing that happens every hour, every month, every week, every day on any Windows machine unless you go in and you configure it, So it's quite different comparing Linux to Windows in this aspect. So with that, let's create our own cron file. I'm going to clear the screen. I'm going to go back to our home directory. And we had created a script here called usernum. That's what I want to automate. First off, let's put that in the cron file to run just start off every minute. So if I vi/etsy/cron tab, I can go down here and I could put that script in Etsy cron.hourly, or I can add it to the end of this myself. So if I want to run every minute, every hour, every day. We'll fill all those in. And we added the user num script to run every minute. Let's try this out. Obviously that's not practical and it's not something you really want to do. We just want to see if cron will really run this and do it for us. Let's check our mail. Okay, no mail yet. What's going to happen is cron should run this here pretty quickly in the next minute, and we'll get an email message with the output. I tell you what, while we're waiting for that to happen, let's start an @job. Let's do @now is another keyword you can use, and it says, what do you want to do at? You know, what script do you want to run? I just want to run an ls-l, and I'm going to do a Control D right here, and it tells me job 1 was submitted that date, and it's going to run it right now. So I can put in whatever I want to run at whatever time I want it to run. And hey, we have new mail. So let's type mail. And here it says output from your job. So if I select 3, hey, there's the output from our job. It's the ls-l that we told it to run. So this is the output from our @job. So I'm going to delete that and quit out. Let's check our mail again, see if crontab has emailed us anything yet. No. Let's go look at var spool ls-l. Let's cd into cron ls-l. There's nothing in there right now. But this is the spool directory for all cron jobs. Var spool cron. So let's check our mail again. There we go. Finally, we got a new mail. So I'm going to select 3. And here's our script. It ran. There are currently 40 users configured on this server. So this script is going to run once a minute, every minute, by the cron daemon, because that's what we created it to do. So if I delete that out, type Q to quit, let's go back and look at our cron tab file again. Let's take this out. I did DD right there to delete a line. So I'm going to do colon to go down to the command mode, and WQ for write and quit to save this file. So we're in Etsy. Let's cd into cron.monthly and do an ls-l. So let's say that every month I wanted to run that user report called user num script that we created. So to do that, I'm going to create a link. I'm going to create a symbolic link, call it user num, and then I'm going to put in the path to the script. What? Did we make a mistake here? Let's see. It says file exists. Yep, we sure did. What we need to do is do an ln space the name of the script and then the name of the link. There we go. There we go. We had them reversed. So the syntax here to create a symbolic link, we talked about symbolic links just a little bit ago, is ls minus s for a symbolic link, and then the name of the source file. So the source is the file that we're creating the link from, and then the destination is the new name of the symbolic link we want to create. So we said we want to call this user num, and it's pointing to /root/user num. And we put this in the cron.monthly directory. So usernum will run every month, and we'll get an email report that it ran. So I saw here a second ago that we got new mail. Let's check our mail. Oh, and our cron job's still running. So if we do 3 to read that mail, yep, sure enough, 40 users configured on the system. Whoops, H for headers, and then 4, and then delete that out, and we'll quit. So it's a good thing we changed that just a minute ago. It should take effect here, and we should stop getting our email messages. So we created an add job, we created a cron tab, and we did it in 2 different ways. We edited the cron tab file directly, and we also used the cron.daily and cron.monthly directories to show how those directory structures work for the run parts section in the cron tab. So with that, let's go back to our slides. Next on the list, we're going to talk about run levels. So if we go over here to our run level slide, let's talk about Linux Plus Objective 2.10. It says manage run levels and system initialization from the CLI and configure files, for example, /etc init tab and the init command, and then /etc rc.d and rc.local. So some programs in Linux run when the system boots. Some programs are system programs with the purpose of providing a remote access service. So let me give you an example. When the system boots up, by default it starts the SSHD, or the SSH daemon. If you'll remember, we talked about SSH being secure shell. It's a remote access command line tool that's secured and encrypted. So from our PC here, we were able to connect to the server, the Linux server, using SSH. We didn't do anything to configure that. It was installed by default, and it's set to start up. That SSH daemon, or the SSH service, is set to start up when the system starts. So that's an example of a program that starts and provides remote access, or some other service, just about any other service. Could be the CUPS print server to provide remote printing for clients that are using the Linux server as a print server. So these are just examples of different applications that need to start when the system starts. Now, Linux run levels are there to group what services should be running and what services should not. So there are some different run levels right here. Different run levels have different purposes, and these run levels are numbered 0, 1, 3, 5, 6. They have different numbers. You can create your own run level number if you want. And within each of these run levels, different things, different services, I should say, would either start or would be stopped. So if you go to run level 0, that shuts down the server. If you go to run level 1, that's single user mode, meaning no multi-user services are available. There's no networking, in other words. There's no networking or any service that would use networking. Now run level 3 is multi-user mode. Usually this is just text-based multi-user mode. So if you go into run level 3, you don't get the X Windows console with the graphics, but it's a fully functioning Linux server with all multi-user features. So people can connect in by SSH. They can use their print server, file sharing, whatever it is. Now run level 5 is multi-user with X Windows. So same thing as 3, but you get the X Windows desktop. And remember, X Windows is a server application, so you could have X Windows clients out there connecting to your server for the X Windows desktop. So you get that with run level 5. Run level 6 reboots the server. So be warned that different versions of Linux treat run levels differently. The run levels listed above are generalities. So SUSE Linux might have a run level 4, and that's multi-user for X Windows. I don't know exactly. But the point is, different versions of Linux, if you go to the different distributions, they have grouped things differently into different numbers. And I'm going to tell you how to go and find out what starts at what run level. Now the init program is the system initialization program. It reads the etc init tab to determine how to do its job. So the etc init tab file is a file, and we'll go look at that, and it tells init what to do when the system starts up. Each of these run levels has its own directory with scripts telling it what services, daemons, should be started or killed at what run level. So obviously when you go from run level 5 into run level 1, you're going to need to stop a bunch of services, right? Because you're going into single user mode. You're going to stop the X Windows daemon. You're going to stop the cups print server. You're going to stop the SSH daemon, because those are all multi-user applications. So at the different run levels, there's start scripts and stop scripts. That's important to know. Now these scripts are located in etc/rc.d, that's in Fedora, and these are actually links to the full scripts located in etc inetd. So if you want to add your own script, you could put it in etc inetd. And then in the different rc.d directories, you would create symbolic links back to this script over here. So that's how it works. You'll see in the etc/rcd directories, there's just a bunch of symbolic links. Now the scripts in the directories can be run manually with the parameters start, stop, or restart, and there's some other parameters too. You can use these scripts to troubleshoot certain services. So say that the cups print server isn't running. You could go in there and you could find the script that starts it. You could run it and put a start after it as the first parameter there. Now the etc/rc.local file is executed after all other scripts. So if you want something to start no matter what run level you're at, you could put it in etc/rc.local. Now the check config command is used to show what starts at what level. Very handy command. Another good command is ntsysv. It's a text-based utility to set certain processes at certain run levels. This is like a menu-based text utility, whereas check config is like a command line tool. But they're both pretty handy to tell you kind of overall what's going on. And we're going to try out these programs. There's another program you can download on the internet called ksysv. It's a X Windows program, a graphical program, just like this ntsysv. It's called ksysv. It doesn't come installed though by default in Fedora. Now the Fedora Services Configuration tool can also be used to edit what service starts and at what run level, although it's pretty cryptic. It's not really easy to use. Now boot systems to boot systems into different run levels for troubleshooting and maintenance, you can use the different run levels. So say I'm having trouble with networking. Well, I could go into init level 1 where there is no networking. I could check out the different configuration files, maybe edit something, check out log files, and then go back into multi-user mode, run level 3 or 5. So these run levels are used for troubleshooting. If you're having difficulty with X Windows, you could go into run level 3, get rid of all the X Windows stuff, and then go back into run level 5 and it would restart everything. And you can do that without bringing down the entire server. So let's explore run levels and the various related configuration programs on the Big Sky Fishing Supply Company server. We'll move from one run level to another, and then we'll try out these check config ntsysv configuration tools, as well as the Fedora Services configuration tool, and we'll go look at the files and directories over in etc init tab, etc/rc.local, and etc/rc.d. So if we go over here to our Linux server, and I've already got a command line window open for us. First, let's go check out the init tab file. If I cd into etc and I cat init tab, let me scroll up here so you can see the start of it. Alright, it says this file describes how the init process should set up the system in a certain run level. And it defines the run levels right here. 3 is full multi-user, 5 is X11, which is X Windows, 1 is single user, halt is 0, 6 is reboot. So the init default, what the system starts up to by default on this Fedora Linux server is init level 5. So it starts up in X11 by default. If you scroll down here, there's here's the different directories we talked about, and we'll go look at those. So that's the init tab, and there's a command called tellinit q, and we're going to talk about tellinit in just a few minutes. Tellinit tells init what to do. So, but it's tel init, tel init q will tell init to reread this file, this init tab file. So say you added something in here, you wanted to reread it and do something, you type tellinit space q to reread this file. Of course, you could also just reboot the system. Now let's go look at the etc.rc.d directories. I'm going to cd into rc.d, do ls-l, and here's these different directories: rc0, rc1, 2, 3, 4, 5, 6. If we cd into rc.5, rc5.d, there we go, and do an ls-l, you can see in here are all these links. I was talking about how these are all links. Now anything with a K means it's going to kill something, it's going to stop something. Anything that starts with an S means it's going to start something. And these numbers here, this is the sequence that it does it in. So it's going to first, in run level 5, if you go into that, it's first going to start this, then start kudzu, then start CPU speed, then IP tables, ISDN, network, syslog, and so on and so forth. When you exit init level 5, it's going to stop these things up here in this order. So notice that these are just symbolic links over here to the real programs that are in etc init.d. So let's go look at those. etc init.d. So here's the real scripts. These are the real scripts over here. And you can see these are just scripts. If I cat out yum, well, let's pipe that to more. It says this shell script enables the automatic use of yum. It says the config file, and then so this is a shell script. You know, we talked about shell scripts. This is a shell script. So if there was something that needed to be, changed with this, you would need to know how to do shell scripting. So those are the etc.rc.d directories, and the symbolic links in those directories point over to the real scripts that are in etc init.d. So now let's look at the rc.local file. Let's do an ls-l. Here it is right here. So we're in etc.rc.d, and if I cat out rc.local, okay, this is the file that's run after init executes all the scripts in the rc whatever run level you're at directories. So after it executes those scripts, it runs this. So you can put your own initialization programs in here if you don't want to use these more complicated directories over here. So that's what the rc.local file is. rc.local runs after all other initialization programs and scripts. So now let's try out check config. Okay, if I just type check config, it tells me how to use the program. So check config --list is used to list out all the services, or you can specify the name of a certain service. So I'm going to do check config --list. I'm going to pipe that to more. So it tells me here at the different run levels. So here's run level 0, here's run level 1, 2, 3, 4, 5, and 6. What's going to start and what's not. So for instance, let's go down here and find something that's of particular importance. Okay, here's SendMail. We were talking about SendMail. SendMail is the mail server. So it doesn't run at 0 or 1. It'll run at 2, 3, 4, and 5, but not 6. So with the check config program, you could go in here and modify what run level SendMail will run at. You could turn it off for 5 or on for 1 or whatever it is you want to do. That's what you do with check config. It's all command line based. So now let's look at NT-sysv. So this is the exact same thing as check config, but it's sort of a menu-driven color interface. So it says what services should be automatically started. Using your arrow keys, you can scroll through these, and you can push the space bar to select one, F1 for information on a service. You can hit, oh, I hit F1, and it brought up the terminal manual back here. GNOME terminal manual. We don't need that right now. Let's close that out. Let's go back here to our terminal window. So this is NT-sysv. Not real easy to use, not real fun. I think I'd prefer the command line or a graphical tool. The KSysv program you can go out and download on the internet is very nice, and it'll do all the services modification in a graphical window. So I'm going to hit tab and I'm going to hit cancel there. So another one that's built into Fedora is the Fedora Services Manager. So if I go to System, Administration, and Services, it brings up a graphical services management application. So these are background services here. It lists out all the different services. If you click on one, it tells you what it is, and it tells you whether or not it's running. So right now it's running and the PID number. I can check it or uncheck it here, and that would mean that it would start in this run level 5. That's what I'm editing, run level 5. Or I can manually stop it. Let's stop a service. It was stopped successfully. Tells you here it was stopped. Or I can start it. So this is similar to the Windows Services program, where you stop and start services. But in here you also tell it whether or not you want it to run automatically when the system starts, same as the Services program in Windows. But then there's also the concept of run levels. What run level do you want it to run automatically at? So this is the Services configuration program. Alright, so now let's try out the tell init program. So tell init is what you use to tell init to go to a certain run level. So if I do tell init 1, I go to standalone user mode. Or tell init S goes to standalone user mode. Or single user mode. Standalone, single, it's the same concept, but it's run level 1. So it doesn't have all the multi-user services. Telnet 3 takes me to multi-user mode without X windows. And Telnet 5 is what we're already at. Telnet 6 would reboot the server, and Telnet 0 would just immediately halt the server. So those are the different Linux run levels. With that, let's go back to our slides. So in this section we learned about Linux run levels. We learned about the init tab file. That's what init uses to know what to start up when the system starts and the default run level. The default run level in Fedora Linux is 5. That gives you X Windows multi-user services. We learned about the rc.d folder, and underneath that there's other directories, one for each run level. And in those directories are symbolic links that point to the init.d directory, and that's where the actual scripts are that start or stop the different services on a Linux server. We learned about the rc.local file, and that's the file that's used to run any other service you want to run after the rc run level scripts execute. We looked at the check config program and the NT-sysv program. These are command line tools used to edit what runs at what run level. Then we looked at the Fedora Services graphical utility, and that's also used to edit what runs at what run level, as well as start and stop services. We saw the tell init command. It's used to tell init what to do, what run level to go to. S stands for single user. Q will tell it to reread the init tab file. 1 is the same as S, single user. Run level 3 is multi-user. Run level 5 is multi-user with X windows. Run level 6 will reboot the server, and run level 0 will halt the server. So now that we learned about run levels, we can move on to our next slide, which is tuning kernel parameters. Now, something that every administrator should know how to do is to tune the system's kernel. This is done to increase performance or modify a critical system parameter. For example, if you have a heavily loaded web server, you may need to increase network buffers on that server to give it higher performance to be able to service all the different requests. Now, most of the time you won't have to work with kernel parameters. You know, this isn't something you do every day. Just like on a car, you don't go in and tweak the carburetor every day. You know, this is tuning. This is performance tuning, or it's enabling maybe a very special feature of the operating system. But it's important to know what it is and how it works, because you never know when you'll need this knowledge. Now, kernel parameters are defined in text files. These files are in /proc/sys. Then the sysctl, or system control program, is used to modify and set kernel runtime parameters. You can, of course, also edit the text files in /proc/sys, but it's recommended to use the sysctl program. For more advanced information on this topic, see this website where they have an article called Linux Kernel Tuning System Control, and it's at System Administrator Magazine, samag.com. It's a good article on the sysctl program and how it's used to modify kernel parameters and the different performance increases you can get by modifying those kernel parameters. Now let's go over to our Linux server and just take a look at the sysctl program and the /proc/sys directories. Alright, so if I cd into /proc/sys and do an ls-l, you can see there's these subdirectories. So if I cd into one of these subdirectories, like cd space net, do an ls-l, there's some more directories. If I cd into, say, IPv4, do an ls-l, there's these files. So these are like TCP configuration files for how the TCP/IP stack in this on this Linux server functions. So if I scroll up through here, there's even some other subdirectories like routing. But here's like IP forward. This is whether or not you want this server to be a router. So if I cat IP_forward, you can see there's a 0 here. So this feature is off. If I edited that text file and put a 1 in there, rebooted the server, IP forwarding would be on. So some of these are on and off, and then some of them are actual sizes. Sizes of, say a buffer or a queue or a memory size. Some of them are actual numbers like that. Most of them are either on or off. So I can edit this using the text file method, or I can use sysctl. Sysctl is used to edit those files for me. So you see here one of the parameters is variable equals value. So I could say IP_forward equals 1 to modify it. Sysctl-a will show you all these different parameters and their values. So that looks like something you would want to pipe to more, right? Okay, so here it is. You can see some of them are 1 or 0, on or off. Some of them are actual numbers. Sometimes they're even words. But if I scroll through here and I find net, see if we can find it, net IPv4 wow, there's a lot of these. Tell you what, the best way to find IP forward whoops, that scrolled by way too fast. Ah, see, we have to list the directory. Let's do man sysctl, and let's see how these are defined. So sysctl minus n minus e variable will show us the variable. So sysctl minus n minus e net dot IPv4 dot IP underscore forward. There we go. There we go. So that's how you view these variables. Their directory name, because that was the first directory, then the subdirectory, IPv4, then the variable. And there could be, multiple subdirectories or just one subdirectory. So that's how you view these different variables. And then here I could do value equals and I could set it. So if I wanted to change this, I could do value equals 1 like that, and I just set that variable. Now if I cat out IP underscore forward, notice it's set to 1 now. So the sysctl program set that IPv forward from 0 to 1 with my command line right here. So if you know what you're looking for, you can go in here and change it. But a lot of the times you might be changing buffers or features like IP forwarding, things like that. Hopefully, though, you never have to go in here and mess with this. But it's important just to know, what it is and how it works and what these kernel runtime parameters are. So with that, we can go back to our slides. And that brings us to the conclusion of video number 9, Linux System Administration Part 3. In this video we learned about managing and accessing mail queues. We learned about the mail program, the MUT text-based mail program, and then Evolution, the graphical mail program. We learned how SendMail is the Linux mail server by default, and there's also Postfix as an alternate mail server. We talked about scheduling jobs with @ and cron, and how @ is used to run jobs that are going to be run in the next 24 hours and a one-time job. We learned about how cron is for any jobs that are periodic. You want to run a job every day, every month, every week, whatever it is. Cron is for periodic jobs that are recurring. They happen more than once. We talked about managing run levels, the different run levels. 0 halts the server. 1 is single user mode. 3 is multi-user. 5 is multi-user with X windows, and 6 reboots the server. You use the tellinit command to change from one run level to another. We learned the check config command to see what services are running at what run levels and to modify those run levels, as well as the ntsysv and the Fedora services programs. We talked about the rc.d directories and how those are symbolic links that point over to the init.d directories where the actual programs are located. Then lastly, we learned about tuning kernel runtime parameters using the sysctl or system control program. So that's the end of video number 9. Thank you very much.